Hello everyone, my name is Amrit and first chapter in 11th grade physics and name of that chapter is what unit and measurement. Basically it's a second chapter if you look at NCERT. First chapter is physical words, it's all about history of physics, so everyone can read that first chapter physical word, and mostly they don't ask any question from first chapter from physical words. So basically we start from unit and measurement. So in unit and measurement, first thing is physical quantity. Physical quantity. Physical quantity. Physical quantities. Physical quantity means any quantity which you can measure. Quantity which can be measured. So definition of physical quantity means quantity which can be measured. Quantity which can be measured, that is called physical quantity. Any quantity which one you are able to measure, that is called physical quantity. For example, length of something you can measure it, and volume of something you can measure, time you can measure. Like if someone crying you cannot measure, someone is smiling you cannot measure. So if someone is smiling expression, like any psychological expression, you cannot measure it, so it's not a physical quantity. If someone is smiling, you cannot measure. If someone laughing, you cannot measure how much it's laughing or not. So these are not a physical quantity. Physical quantity means any quantity which you can measure. For example, length of a rod, you can measure it. Weight of something, you can measure it. Time, you can measure it. So anything that you can measure, that is called physical quantity. If you are not able to measure that one, that is not a physical quantity. So physical quantity means what? Which you can measure. So basically physical quantity also we can divide into two parts based on their direction and based on their dependency. So based on direction of physical quantity, we can divide into two parts again. See, physical quantity we can divide into two parts. First one based on direction. Based on direction, and second one based on dependency. Based on dependency. Physical quantity we can divide into two parts. First one based on direction and second one based on dependency. Based on direction means what will be direction of the quantity, like direction will be there or not. So based on that thing if you are dividing, so that is what based on direction, and it depends on how many things. If based on that one we are dividing, so this is called based on dependency. So based on direction there are two quantities. I think everyone know this thing. In 9th 10th grade we have done. Based on direction, one quantity is called scalar. Scalar quantities. Scalar quantities. And second one is called vector quantities. Vector quantities. So this one based on direction. One is scalar quantity and second one is called vector quantity. And now what is a scalar quantity? Scalar quantity is quantity which only depend on its magnitude. Like to represent that quantity you don't need anything else rather than magnitude. For example, if I say mass of the body. So mass of the body 10 kg. So nobody will ask mass of the body 10 kg in which one direction. So we need only one thing to describe that quantity, that is magnitude. So that quantity is called scalar quantity. Just like length is a scalar quantity. Like length of something is 1 meter. Let's say length of one rod is 1 meter. In that case, nobody will ask which direction length will be 1 meter. So if we don't need direction to represent any quantity, that quantity is called scalar quantity. Example of this quantity, there will be mass. Mass is scalar. Second one we can write distance. Distance is a scalar. Third one we can write speed. Speed is scalar quantity. Fourth one we can write time. Time also is scalar. Time we assume that it's scalar. Actually it's not a scalar quantity, not even vector also. So leave that thing, but time being right now time we consider as a scalar quantity in classical physics. So whatever physics we'll do in 11th grade based on real time observation, this physics is called classical physics. In classical physics, time we can consider as a scalar quantity. Actually it's not, but in classical physics we consider as a scalar quantity. So right now in 11th 12th syllabus we only do classical physics. So in classical physics it says scalar quantity. So there are 4 examples of scalar quantity. First one, mass, distance, speed and time. Not only 4, there are many examples, but right now I am writing only 4. So what's a scalar quantity? Any quantity which have a magnitude only. Means if you want to represent any quantity, you don't need anything, just you need magnitude only. In that case, that quantity is what? Scalar quantity. For example, speed. Our speed is 10 meters per second. It means we don't need any direction for that one. Time 12 o'clock. In that case, we don't need direction, but 12 o'clock in different direction. So distance, mass. So for these all quantity, we don't need any direction. So that is called scalar quantity. Now, if we need direction as well as magnitude, direction as well as magnitude to represent any quantity, if we need direction as well as magnitude, that type of quantity is called vector quantity. And one more thing, vector quantity means there must be direction, there must be obviously magnitude, direction, and one more line. For more specific definition, one more line should be there. Vector quantity which have a magnitude, which have a direction, and it will follow vector law of addition. So vector quantity means it should have a magnitude, it should have a direction, plus it should follow vector law of addition. So if something is vector quantity, that should have a magnitude, that must have a direction, and as well as it should follow vector law of addition. Vector law of addition. Now what is vector law of addition? Later on we will do, just right now we can assume it's some mathematical law. So if something is vector, so it should follow vector law of addition. It should have a direction, it should have a magnitude. This type of quantity called vector quantity. An example of vector quantity, we can say displacement is vector. Second one, weight is vector quantity. Third one, velocity is vector quantity. Fourth, force is vector quantity. This quantity need direction as well as magnitude to represent themselves, and they will also follow vector law of addition. So these are 4 vector quantity. Not only 4, so many vector quantities are there, torque, angular momentum, so many. But right now I am writing 4 vector quantities. Right now we completed 2 things. One is scalar quantity and another one is vector quantity. What is a scalar quantity? Quantity which have a only magnitude, that does not have any direction. Now what's a vector quantity? Quantity which have a magnitude, which have a direction, as well as they must follow vector law of addition. And what is vector law of addition? Later on it is some law based on mass. Later on we will do that in vectors. So vector which should follow vector law of addition, and there are 4 examples of vector quantities. Right now I am writing, there are many examples, but right now I am writing only 4. One is displacement, second one is weight, third one is velocity, and fourth one is force. So this is the classification of physical quantity which you can measure based on direction. So physical quantity means any quantity you can measure based on direction and based on dependency. Based on direction, again we divide into 2 components, scalar and vector. Now we'll see based on dependency what we can do. Based on dependency also we can divide this quantity into many parts. Like one quantity depend on another one. So that is called based on dependency. Here, if one quantity does not depend on any other quantity, based on dependency you are doing, if any quantity does not depend on any other quantity for their complete definition, that is called fundamental quantity. Means based on dependency we are dividing this quantity into another quantity, that is called fundamental quantity. Fundamental quantities, and here derived quantities. Based on dependency, I divide this quantity into 2 parts. First one is fundamental quantity and second one is what? Derived quantity. Fundamental quantity means quantity which does not depend on any other quantity for their complete definition. For example, length. meter. So meter scale is one operators, and if you want to see the time, you cannot use meter scale for that. So for meter scale only use for length. So if you want to measure length, in that case you have to use meter scale. It means meter length that does not depend on time, does not depend on anything else. So that is called fundamental quantity. Another example I'll give you, just like time. For time you need watch. You cannot measure time using weighing machine. You cannot measure time using meter scale. So for time specifically you need watch. It means time does not depend on anything else. It's only like to measure time we need only one instrument, that is called clock. So if one quantity does not depend on any other quantity for their complete definition, that is called fundamental quantity. If depend on any other quantity, that is not a fundamental quantity. So example of fundamental quantity, just like first fundamental quantity is mass. See, if you want to measure mass, you need weighing machine. You cannot measure mass using rod, using time, using clock. You need weighing machine. It means this mass does not depend on anything else for their complete definition. Means if you want to measure mass, you need only weighing machine. From anything else, if you want to measure mass, you cannot measure. It means mass does not depend on any other thing. It's only it can be only measured by weighing machine. So it's a fundamental quantity. Second quantity is length. Length also fundamental quantity. Why? Because if you want to measure length, you need meter scale. Without meter scale, you cannot measure length. Means you specifically you need meter scale. If you have a watch, you cannot measure it. If you have a weighing machine, you cannot measure the length. So length is also fundamental quantity. Third one is time. For time, you also need watch. Only watch, from watch you can measure. Obviously it can be digital, analog or any watch, but you need watch to measure time. And fourth one is current. For current we need ammeter. Without ammeter we cannot measure current, and we need specifically ammeter for measurement of current. Fifth one is luminous intensity. Luminous intensity. For this one we have the instrument, and unit for this one is called candela. We have a specific instrument for this one, and we measure luminous intensity in terms of candela. Just like mass we measure in kg, length meter, mass kg, length meter, time second, current ampere. Similarly, we measure luminous intensity as a candela. Candela is unit of this one. We represent by CD, candela. Now, sixth one is temperature. Sixth one is temperature. Temperature we measure by K. And one more quantity there. Seventh quantity, that is amount of substance. Amount of substance. This one we measure by mol. So basically there are seven fundamental quantities. First one is mass. We measure this one by kg, like unit of this one kg. Second one length meter, time second, current ampere, luminous intensity candela, and temperature Kelvin, and amount of substance mole. It means this quantity does not depend on any other quantities. So that's why we say this quantity as a fundamental quantity. Now derived quantity means any quantity which can be derived from fundamental quantity. Any quantity which can be derived from fundamental quantity. Any quantity which can be derived from fundamental quantity. Fundamental. See, these are fundamental quantity, these 7. Any quantity which can be derived from these 7, that is called derived quantity. Example of derived quantity, just like speed. Speed is what? Distance divided by time. Basic formula of speed, if you see, distance divided by time. So, speed is distance divided by time. It means distance is what? Length, and time is what? Second. So if this one is length and this one is second, so length is what? Fundamental, and time is also fundamental. So length and time fundamental, and using length and time we derive speed. It means length, distance is fundamental, time is fundamental, but this speed is what? Derived, because speed we derive using distance and time. Similarly, we can derive acceleration. Acceleration means what? Speed divided by time. Actually, acceleration is not speed divided by time, but in this chapter we can write simple formula: acceleration is equal to speed divided by time. Actually, acceleration is equal to change in velocity divided by time, but here we can write speed divided by time. Acceleration, speed is what? Derived quantity. This one is what? Time, fundamental, but this whole thing will be derived quantity. So again, acceleration is derived quantity. Speed is what? Derived quantity. Similarly, force is what?